Hi to all. Today's topic is potentiometer. I am going to explain the potentiometer. This is very important topic for the board exam CBSE or any other state board. Now let us start the potentiometer concept. Now what is a potentiometer? First of all, what is a potentiometer? Potentiometer is a device used to measure the potential difference or EMF without drawing current. What is a potentiometer? Potentiometer is a device that will measure the potential difference or the EMF without drawing any current. Okay? It cannot draw any current, it can measure the potential difference. A device used to measure the potential difference that is called as potentiometer. But what is the difference between the voltmeter and potentiometer? Generally, we will use the voltmeter also to measure the potential difference. But here, potentiometer is also we are using to measure the potential difference. The difference is that voltmeter draws the little amount of current while measuring the potential difference. But our potentiometer cannot draw any current while measuring the potential difference or EMF. That means our potentiometer gives the accurately than the voltmeter because it cannot draw any current. Okay? Why the potentiometer is preferred than voltmeter? Because potentiometer measures the potential difference without drawing any current. It cannot draw any current. Then how potentiometer can measure the potential difference without drawing current? And now what is its principle and what is its construction, that all the things we are going to discuss now. Let us start. And for that, first, what is a potentiometer? It's a device used to measure the potential difference or EMF. Its construction, its diagram will be like this there. And let us see how it will be appears. Actually, this is a practical. In our CBSE, it's practical also there. And look at here. This arrangement is fixed on a wooden board. Wood arrangement, this one. Look at here. Here we have a one battery, right? And now this is the battery internal resistance. Battery EMF is E0. Battery internal resistance R0. This is rheostat. Its resistance is RS. And plug key K. And the both ends are A and B. Okay. These are all connected in the series. And between the A and B, we are connecting 1 meter wire. This is a manganese wire. 1 meter wire, 1 meter wire, 1 meter wire. From here to here, 1 meter length it will be there. Then like that, 4 to 10 separate 1 meter wires, they are connected in like this. Here 1, 2, 3, 4, 5, 6. Like this, here there are 4 to 10 1 meter wires. This is a 1 meter wire, this is a 1 meter wire. Generally 10 meter wire we will take. Okay, this is 1, 2, like this, 1 meter wire, 1 meter wire, 1 meter wire, 1 meter wire, like this. Here 10 separate 1 meter wires are connected by using copper strips. This is 1 meter wire and this is 1 meter manganese wire, this is 1 meter manganese wire. All these 1 meter manganese wires are connected by using copper strips. Look at here, from here 0 centimeter we are taking, up to here the wire length is 100 centimeters, means 1 meter. Then by using copper strip with a screw we will fix, and then this is connected to another manganese wire of length 1 meter. Then from here to here 100, next from here to here 100 centimeters. The total from here to A to this point is 200 centimeters. Then again connected with one copper strip and again 1 meter wire. Then 200 up to here. Then again plus 100 is added, from here to here 100 length 300 centimeters. Like this, here when you will go here 400 centimeters. When you will go here 500 centimeters, because plus 100 is added, right? And now like this construction will be there. Let us consider here at point A we are connecting the 1 voltmeter. I want to measure the potential difference between these 2 points. This wire length I will take as L. This wire length I will take as L. I want to measure the potential difference between the A and J. Okay. How we will measure the potential difference between the A and J? Okay. In these terms already I said what are the terms, what is Kepler, what is E0, what is RS. Okay. Now look at here. Principle I am going to explain. What is its principle? Okay, first I will tell this also. What is E0? E0 is the EMF of driving cell. I is the current in the circuit. In this, some current passes through the potentiometer wire. Between A and B, we are connecting one wire whose length is nearly 4 meter to 10 meters, right? And generally we can take 10 meters, okay? And the I is the current through the driving circuit. This total circuit is said to be driving circuit, and E naught is the EMF of driving cell. This circuit is the driving circuit. This cell is the driving cell. Its EMF is EMF of driving cell. I is the current in the driving circuit. Rs is the resistance of rheostat. This one, and R naught is the internal resistance of driving cell. Its internal resistance is R naught. Capital L is the length of potentiometer wire, right? Potentiometer wire is in between A and B. This length, right? Its length is from 4 meter to 10 meters. Different potentiometers have the different lengths. Okay, in our lab we have 10 meter wire potentiometer, right? Now capital R is the resistance of potentiometer wire. That means this wire, total wire, has 10 meters length, and that wire resistance is capital R, and A is its area of cross section, right? Okay, and now what is its principle? The principle of potentiometer is that when constant current passes through the uniform cross section of potentiometer wire, in this, if constant current passes, the battery supplies the current, right? When constant current passes through the potentiometer wire through uniform cross section of potentiometer wire, when constant current passes through the uniform cross section of potentiometer wire, the potential difference between any 2 points is directly proportional to the length. Here, for example, constant current is passing, area of cross section of the wire also constant. At that moment, potential difference between any 2 points, for example, I am taking the potential difference between these 2 points A and J on the wire. Okay, current flows from A to B, right? This is the positive terminal, and next it is connected to B. This is the negative terminal. That means current flows from here to here like this. Here high potential will be there, here low potential is there, because current flows from A to J. There is some potential difference is there. If you want to measure the potential difference, right, that potential difference is directly proportional to the length of the wire. If you will increase the length, then potential difference also increases. For that, you can connect one voltmeter at here. Okay, when the voltmeter end is connected to jockey, when you will connect the voltmeter in between these 2 points, it will show some potential difference. For example, you can increase the length. Here you can connect. The length is increased, means the potential difference also increases. Means the principle is that very simple. The potential difference is directly proportional to length. Okay. Now I am going to tell the proof of this principle, and for that I am taking a wire of resistance R dash and length L. Potential difference across that wire V is equal to potential difference across that wire. Potential difference equal to current into resistance. That potential difference across A and J I want. In this current is I. Resistance of this AJ wire is R dash. Then potential difference is equal to I into R dash. Okay. I will continue. Now I am going to rub this. Take the screenshot and note every point. Okay, look here. Potential difference is V equal to IR dash, but R dash is the what? Resistance of the wire whose length is L. But R dash formula we write according to Ohm's law. But R dash is equal to we write as rho L by A, right? R dash is the resistance. Resistance formula we know already, rho L by A, where rho is the resistivity or specific resistance. Resistivity or specific resistance. Okay, L is already we know. L is the length of potentiometer wire. Okay, potentiometer wire of potentiometer wire in between points A and J, right? In between points A and J. And now A is the area of cross section, that is already you know, area of cross section of wire. This we substitute in that equation. Okay, this is equation 2. For example, this is equation 1. Now equation 2 is substituted in equation 1. Equation 2 is substituted in equation 1. Then what you will get? That is V is equal to IR dash. IR dash, but R dash is what? Rho L by A. Okay, here you have to remember that we should not write capital L. Why? Capital L is the total length of potentiometer wire, but we are taking the potential difference between only A and J. Here like this wire is there, this is A and this is J. I want the potential difference between only these 2 points. Its length is L and its resistance I am taking R dash. Current is I. The potential difference is current into resistance IR dash, but resistance formula we write as rho into L by A, right? Rho L by A. Full length we should not take because potential difference across full length of potentiometer we are not finding. We are not finding the potential difference across full length of potentiometer wire. We are finding the only part of potential difference across the 2 points whose length is 2 points of wire, potential difference between 2 points of wire whose length is small l. Right, here we write like this, and then we can simplify this. I rho by A into L we write. Okay, then but I rho by A we can consider as phi. Okay, V is equal to, we write as phi L. This sum is some constant. Rho is the resistivity of wire, constant. Rho is the resistivity of specific resistance, it is a constant. A is area of cross section, constant. I constant. This totally constant, we write phi, it is. And L is the length. We can increase the length of the wire. From this we write potential difference is directly proportional to length of the wire. Potential difference is directly proportional to length of the wire. Here phi is we can write V by L. Okay, that is called as potential gradient. Let us go for that phi. What we said here, phi. Okay, potential gradient. Potential gradient that is denoted with phi. What is potential gradient? Potential gradient is what? Let us see what is the potential gradient. And for that here you know potential gradient is the, from this formula we write V by L from equation 3. Okay, from equation 3 we write V by L, right? V by L we write means potential drop, definition we write potential drop across potentiometer, potential drop across any 2 points of potentiometer wire, potential drop across potentiometer wire per unit length is called as what? Potential gradient. It is very simple. It is a potential drop by length, that is potential drop by length. Potential drop by length, and this we write as V by L also. V by L. Okay, and now this formula we can also write like this. V is equal to, V is full length I want to take. Full length potential drop is V and full length of the wire is L, and V formula we write as IR because potential difference across full length of the wire means current through full length of the wire and resistance of the full length of wire we have to take. Resistance of full length of wire is capital R, by L we write, and R is equal to, we can write rho L by A. Okay, R is equal to, we write as rho L by A, then I into rho capital L by A by L we will get. Here the formula we can also get is I rho by A. This is the potential gradient formula. Again I derived. Okay. But already from here also we write the potential gradient formula I rho by A. Directly also we can write. Okay. Now if you want you can write directly also. Yes, already we derived in previous case. Directly also we can write. That is we will get is I rho by A, right? I rho by A. Or otherwise you can write completely, there is no problem. I R by L, and here I into R is rho L by A by L. Then we will get potential gradient formula is I rho by A. This is the formula, right? Here also we are considering phi. Phi is what at here? This I rho by A we are considering as phi. Okay. Here we are taking I rho by A as phi. The same formula, right? Okay. And now let us go for how much current passes through the potentiometer wire. How much current passes? How to derive the formula for the current? Current formula, you know, effective EMF by effective resistance. Current formula is effective EMF by effective resistance. That formula we can use and we can find out. Okay. Now the current through the potentiometer wire. Current through the potentiometer wire. Current through the potentiometer wire. How to find out the current through the potentiometer wire? The current formula we know already. Basically we know that is effective EMF by effective resistance in the circuit. Effective EMF by effective resistance. Now how to find out the effective EMF in the circuit? We know already in the circuit like this it will be there. There is a driving cell, its EMF is E naught, its internal resistance is R naught, and some series resistance is there, that is RS, that is the rheostat resistance. In between them this is A and this is B. In between them we are connecting one wire, right, like this. In this, how much current passes through the wire, right? How much current passes through the wire? Like this, the current passes from positive terminal to negative terminal. How much current passes? That I will consider as I. Current formula is effective EMF. What is the total EMF? Only one cell whose EMF is E naught by resistance in the circuit. What is the total resistance? Here internal resistance is R naught, series resistance is R suffix S, R suffix S, this one, R suffix S, and the resistance of potentiometer wire is capital R, its resistance is capital R, full length of the wire. So what is the total resistance? All are connected in the series. We write resistance of potentiometer wire, this wire, resistance is capital R, it is made with manganese or nichrome. And series resistance RS, internal resistance R naught. This is the formula to find out the current through the potentiometer wire. Okay, this is equation 5. Till now what we discussed, right, about the potentiometer. Okay, and now once let us revise everything. Okay, what is potentiometer principle? Potential difference proportional to length. It was very simple. Yes, its proof is V equal to IR. R is rho L by A. Right, then indirectly potential depends upon the resistance, resistance depends upon the length. When length changes, then the potential difference also changes. And next we discussed about the proof of this one, right? Next, potential gradient. Potential gradient, when proportional is removed, we will get a constant, that is phi, where phi is called as potential gradient. Potential gradient. Its formula I gave, right? It is I rho by A. Okay, here we derived. Rho is the resistivity, and the current through the potentiometer also we derived. This is very simple introduction regarding the potentiometer. Okay, and now what are the uses of the potentiometer, right? Where we will use and what to find out by using potentiometer. Let us start. Uses of potentiometer. Uses of potentiometer, right? Let us write the uses. What are the uses? What we have to do? First point is that potentiometer is used to measure the potential difference or EMF. Okay, and the next second point is that potentiometer also used to compare the EMFs of two cells without drawing current. Here, without drawing current. And the potentiometer second use is that potentiometer is used to measure the potential difference or EMF. Second use is that potentiometer is used to compare the EMFs of two cells. Compare the EMFs of two cells. And the next, potentiometer also used to find the internal resistance of a cell. Potentiometer is used to find the internal resistance of a cell, right? In our lab we have this, we can find out everything, internal resistance of a cell. Okay, these are the uses. And now you can take a screenshot and note every point. If you will get the doubt in any step, you can contact me in my WhatsApp number, okay, or you can make a phone call, or you can comment in the down, okay, I will clarify.